Okay, let's have a look at the network communication questions booklet. The very first question was from the 2024 exam, and it asked you to make a bunch of subnets. So let's have a look at it. The question says, we have been given an IP address allocation of 192.168.15.0 and a subnet mask of 255.255.255 terrible fives .0. I might need to write bigger in the future. And then it says, using that, we need to make 3 subnets. So 3 subnets just means different ranges of IP addresses that we can put together to make a smaller section of the network. So 3 subnets. To visualize it, you got 1, 2, 3. Each of these need to have a name. The first one on there looks like it's called Mission Technical. Next one is called Guest, and the last one's called Research and Development. And they're all going to need an IP address range, IP address range, and a subnet mask to match. So all 3 of them need that. And remember, by doing this, you're setting up things like security and so on because they can't talk to each other. But we need to go and set that up. The question also says each one is going to have 60 devices. In a perfect world, we would just go, okay, 60 devices. Well, surely we could just go, first one being 192.168.15.0 to 192.168.15.59, right? 60 addresses. And the next one, we could just add another 60. So we go from 59, add 60 to that, and the next one, and so on. But because it doesn't quite work like that, we need to do a little bit of maths in here and figure out how to actually separate these networks correctly. Okay, first things first. How does a subnet mask work in restricting IP addresses? Well, if it's 255, it means there's 0 wiggle room. You cannot alter that address. So that's locked in. That's locked in. That one there's locked in as well. All we can do is work with that 0 on the end, and we can set our ranges from there. So we need 60 addresses, great, but we need to do a little bit of room to figure out the exact amount of IP addresses because we can't just lock it at 60 in general. Why can't we? Well, let's take the subnet mask. To get a 255, that's when you have binary of 1, 2, 3, 4, 5, 6, 7, 8. All ones, add them all together, that equals 255. So I'm going to lock in that subnet mask at the top. Lock it in again. Dot, and then I've got my zeros. So I go 0, 0, 0, 0, 0, 0, 0, 0. Because it's a 0, that's where we have the variable. So that's all locked in, that's our variable. So this is our network portion, and that there is our host portion. At the moment, with a subnet mask of 255.0, that means we could have 255 addresses total. We need to separate that into 3 and also restrict the amount of addresses. So how do I do that? Well, let me actually write the numbers in binary here. So if I've got all these zeros, well, for each of these you'd have the same, but this is how we calculate the binary. 8, 16, 32, 64, 128. All right, there's my binary value. So you'd go, well, the closest number is 64, right? So why don't I just use 64? Does that make sense? Well, if I go 1, 0, 1, 1, 1, 1, 1, 1, I've made a massive mistake. I'm not allowed to do that. Why? I can't separate the network and host. It has to be, and the network again, it has to be all network, then host. I can't go network, host, network. Like, it doesn't work. So I can't do that. That is not allowed. Let me grab the eraser to remove that. So bad, can't do that. So knowing that, we go, all right, we then need to get the next best thing we can using that rule. So obviously 128 too much. So we write a 1 there. The 1 means it's now part of the network. It's no longer usable for hosts. Great. 64, well, unfortunately, if we just put it all zeros, we're going to get a lot of IP addresses. We won't have enough to do 3 subnets. So we write a 1 there as well. So that means the 64 now is taken by the network. We can't use it. What have we got left? If we add all these together, what do we get? So if we add 32 plus 16 plus 8 plus 4 plus 2 plus 1, doing some really quick maths on that, we get 63. So 0, 0, 0, 0, 0, 0. You go, well, is 63 enough? We need 60 devices. So yeah, 63 would be enough. If we were to take that one off and just go with the rest, we're going to have way too little. So the closest possible one is 63. Now, for those who understand, well, wouldn't all the zeros make an address too? Yes, all the zeros would make an address. So it's 63 plus 1. It'd be 64 total addresses that we have on there. Let me just go over that last bit again. If I was to put in here, add all these numbers together, I would get 63. But remember, we have an address at 0 as well, which is our network address. So I have to add one for that network address. So we get 64 addresses. Doesn't mean we have 64 usable. Actually means we only have 62 usable addresses. Let's have a look at why. So now that that's our binary done, that means our subnet mask is sorted. So our subnet mask would end up being 255, which is that bit right there, .255, which is that bit right there, .255, which is that bit right there, and let me just amend that, .11, and what is 128 plus 64? 190, 192. So that there is my new subnet mask, and you can all see why by adding those two in there. Another way you can view this when you write it is if you add all these numbers together, you get 8 plus 8 plus 8 plus 2. Well, that is 26. Another way that can be written is a /26. That means the same thing as that. That's what that means. If it's a /28, it means that you've got a 0 on the end, essentially. All right, let me rub this out. So we know that that's our subnet mask. I'm going to write it over here because we now can use that for the whole question. .255.192. All right, little point of confusion might be going, well, if it's 192, how are we going to get 60-ish devices for each network? Like 192, no, what it's saying is for each subnet, you're going to get 60 available IP addresses maximum. We're doing 3 subnets, so that means each subnet is going to get a unique 60 different addresses. All right, let's rub that out. Good so far? Good. All right, cool. So we've done our very first one. Now we have to actually assign IP addresses to our subnets. Okay, so the very first question actually asks for subnet number 3, which is this one over here. And we're not going to start with the last one. We're going to start with the first one and work the way at the end. In the question, we have to get all subnets for all different things anyway, so we may as well just figure them all out. It's quite confusing because it's worth 1 mark, this question. And yet it asks for a lot of work, but that's because all of them together make 6 marks, and once you get 1, the rest are pretty straightforward. All right, so our first subnet, this is the mission technical, I believe. Yes, mission technician. The very first address on there is going to be our network address. This is the one that we can't use it. It belongs to the network. It's not ours, but it still sits on there. So the very first one is the network address, and this is 192.168.15.0. So that's reserved. We can't touch that one. The next one is going to be our router, as the question states, or the default gateway. Now, I'm going to be a little lazy here and use some dittos. So it's 192.168.15, and then this will be .1 on the end, okay? It's all the same, I'm just writing different on the end. .1 on the end, okay. The question then states to us, and that counts as a device, by the way. So all the 60 devices, we've now allocated 1. Bless you. So now we need to do our servers, and it says 2nd to 4th usable IP addresses. Note that word usable, because the first one is not a usable address. The network has gobbled it up. We can't touch it, it's not usable. That was our first usable address. The second usable address, this is our servers. This is ditto, 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 .2, and then we got .3 and .4, okay? That's our servers taken up. Done. Then now it says the last usable IP address. Once again, note that word usable. So how do I know what my last address, a usable address? Well, let's find out what the actual last address altogether is. Well, I said there were 64 total IP addresses because 0 counts as 1. So that means my last address, which is our broadcast address. So at the bottom here, I'm going to write broadcast. My broadcast address would be, I'll write it fully out, 192.168.15.63. I can't touch that address. That's not reserved by the network, but it's used by the network to send around. So I can't use that address. It has to stay there. That's when you plug in a new computer and it needs to send the MAC address. It uses that address to send on. We can't touch that one. Which means the last usable one for the network printer, well, that would be the same as that, .62. And then the second last one, which would have been VoIP phone, sorry, it's getting messy now, 61. So 61 would have been VoIP phone because that's the second last usable. The last usable would be the router, which was 62. Okay, so we've actually now completely done our first subnet 100%. First subnet's done. Key points. The very first address on our subnet is our network address. Not a usable address, not an address that we can touch. So that one, done. The very last one, broadcast. Can't touch it. That exists for every single network everywhere. So if the question didn't state it, which this one doesn't have in there, you still have to factor in those two addresses because it always exists like that. Now this question was fancy and it says, hey, well, what about all the other ones? Can you give a blah, blah, blah? Typically, we always have a default gateway. That one typically exists. And then the rest, well, if the question states you need to save them, you need to save them. If it doesn't, then you can just assume they're all usable. Okay, that's the first one done. So we're good with that one. What about this second one over here? We still haven't even got to the first question yet. So what is this one? Well, if the last one ended at a 63, the very first IP address that's not usable has to be our network address. So it's going to be, I'm going to write network. It's going to be 192.168.15.64. That is now our network address. Why? Because the very first address has to be our network address. So we ended our last one on 63 because that was the subnet end. So the next one starts on 64. So if you wanted to jump straight to the end and go, well, what's the broadcast address? Well, that would be 192.168.15 and then add 63 to that, which would get you to 127. All right, what about all the addresses in between? I'm going to be lazy again and just go, can you see? You can kind of see, there we go. I'm going to go, my router is 65. My servers are 66, 67, 68, because it said they take up 3 addresses, I believe. Then I would have my very first available address for my devices. And then at the end, I would have my printer, which would be 126, and my VoIP phone, 125. That's quite messy, but if you're not following along, just rewind, you can see. All right, so 64, network, router, 65, servers, 66, 67, 68. Then I'd have all my devices in the middle. Then I would have my VoIP, which would be that one there, my printer, that one there, and my broadcast. All right, we've now done 2 subnets. Now we're getting to the very first question, and you'll see we've actually answered all of them by doing this, but this is just getting us to the first one. So the first question actually says, well, what is the subnet mask? What is the network address and the subnet of the the third subnet, which is research and development? That's what we're going to do now. So if this one ended on 127, that means our third subnet starts on network 192.168.15.128. That is our network address. We can't use that address because it's the network one, but that's our network address. So we're starting on 128. Then we'd have our router. And hopefully this is getting tedious now that you're seeing, yeah, I get it. Next one will be 129 for router. Then you have your servers, which are going to be 130, 131, 132. And then where would that end? I mean, what would be the end of that one? Well, if we add 63 to 128, I think we get 191. Yes. So our broadcast, which is the end of our network, is 191, which means that our printer would be 190, and means our VoIP would be 189. All the addresses in the middle of computers. Hopefully that math makes sense. Hopefully that adds up. So the very first question asks for two things. It says, hey, what's the network address? Let me draw that one. What's the network address of our third network? Well, I've done it there. So let me go question AI. Network address was 192.168.15.128. Yay. Then it says, what's the subnet mask? Well, we set that subnet mask at the very start, remember? This is the one that restricts it. So that would be 255.255.255.192. Yay! Now this is where it gets really easy, and we're almost done with the video now, actually, because the next one, II, it says, what is the IP address and subnet mask for the first connected wireless notebook on the guest Wi-Fi? Well, we've already got the subnet. I'm not going to write that again. We've already done that. What is the first connected notebook? Well, let's have a look at the network. This was, the guest network. It's not 64, 65 is the router, 66, 67, 68 are all the servers. So it must be 69. So it'll be 192.168.15.69. Done. Remember, the subnet mask is the same there. Then we go to the next one. The IP address and subnet mask for the wired printer in the mission technical subnet. Well, we've already got that there because we did that one here. And we said it was this one here, right? It's the second last usable. So now III, that would be 192.168.15.61. And the subnet mask, once again, the exact same. Then it says the IP address and subnet mask for the router port on the guest subnet. We've done it already. It's this one just here. I'm actually going to write that one out. 6,555. And the subnet mask is the same. The IP address and subnet mask for the first connected server in the research and development. Right there, we have done it. So all that work we did to get to here, we've answered all of them really fast because now that's all of our answers. And then after that, it goes on to different network questions. So that's how we subnet a network, how we set it all out. In this booklet, there is many practice questions. Little heads up, if the subnet mask has a 0 there, it means that can change, meaning your available addresses go from being, just a little bit, 255, 253 really, because network and broadcast. Now you're adding in a lot more addresses, like way more addresses. So factor that in when you answer those questions.